Often, we have a larger data set than we need and really only want to analyze a subset of our data. Here we have pollution readings where columns represent days of the week and rows keep track of the time. We want to understand pollution levels by looking at data from different times and days. How can we extract subsets of a matrix for analysis? Elements of a matrix have a row index defined by the row number and a column index defined by the column number. For instance, the element in row 5, column 3, has indices 5, 3. To access this element, we include both the row index, then the column index, separated by a comma and enclosed in parentheses. But how would we extract a larger subset of a matrix, say the data that are in both rows 1 and 5 and in columns 2 through 4? Instead of accessing each element one by one, we'll access all of these elements at the same time. To do this, we'll first create vectors specifying the row indices and column indices we need to extract. So here, the variable rows is a 2-element vector of our desired row indices, and the variable cols is a 3-element vector of our column indices, which we enclose in parentheses. And look at that! The result is a 2x3 matrix containing exactly the subset of data we wanted. When analyzing data, you might find yourself needing to extract an entire row or column. Extracting a whole row or column of data is so common, there's a shortcut. A single colon references all of the elements in that dimension together. That's better. Here, the colon in the row dimension indicates that we want all of the rows, and the 1 in the column dimension references the first column. And now that we have only the data we need, we can continue our analysis. Because the first column represents readings on a Monday, we can conclude pollution levels rise quite a bit on this weekday afternoon.